Hello guys, I think we're live now. Sorry for the delay. I'm nearly 10 minutes late, but yeah. I hope everyone's doing amazing in this Wednesday evening. And I'm waiting still to hear myself to make sure that we're live, because I'm not too sure. But I think we're good now, right? Let's see. No, we're still not live on YouTube. But there you go, yeah, we are good now, right? So how are you guys doing? It's good to see everyone. Well, there's no one in here yet, but it's good to see people in the future. And we're going to do some more Python. Today we're going to actually work a little bit towards relearning all of the machine learning stuff that I once knew. As a fun fact, I actually studied a lot of machine learning at university. So in my second year onwards, I focused a lot of my time studying some of the machine learning like algorithms, how to train things properly, how these models kind of work. And since I finished university, the truth is I haven't really had that much practice in it, and therefore most of that knowledge has kind of gone away. But yeah, we're gonna try and relearn everything again. Hello Robin, how's it going, dude? I'm still using the playlist you sent me yesterday, man. It's a pretty good playlist actually. No copyright strikes in the last video, so I love when that happens. But yeah, I mean, thank you for the playlist. So the plan for today is the following, right? The overall plan for the next few videos is to be able to train a neural network with some data, right? So I kind of like doing computer vision, so that's working with images in well, machine learning really. And the idea is so is that we can train a model that will recognize a few images. So for example, you give it pictures of rice and it will tell you which kind of rice it is, and that's the idea of it. But obviously we're not going to be able to do that all in the 2 hours that we have allocated for this stream, because it's a long task actually. But a good step is to actually, once you download the data set with all the images, then we can split the data set into a test and a training set. And you can, most people when they're starting out, they do something like 10% of the images will be saved for the test, and then 90% of the images will be actually used for training the model. And the reason why you split into test and training set is so that you can use images that your model has never seen before in the training stage to actually test your model, right? That's why we have this whole split. And I thought, why not? Let's do this on a pipeline and see how it goes, right? So yeah, I mean, let's talk a little bit about data sets actually, because obviously to be able to train a model, you need to have data. And a good place to find like free data out there to train models is Kaggle. Kaggle has a lot of data sets that you can just kind of download and play around with. One of them, as I said, is the rice data set. So it has 1, 2, 3, 4, 5 different types of rices. And the images are separated into folders where each type has kind of a lot of samples here. So you have I think it's 2.5 thousand samples in each category. I believe it is anyway, so we can take a look at that anyway. I wonder where it says that actually. There you go. So 2.5k, yeah. So each, this is a lot of images, and it should be enough to train a basic neural network to kind of recognize images. So yeah, I mean, let's try and kind of firstly download this locally. Let's create a directory so we can train, so we can develop all our tools. So I'm not sure actually if we use the same sort of structure, or if we had a directory or a repository for the last video. I can't remember now. And you see my development folder is too littered with a lot of stuff, shall we call it. So machine learning anywhere. I can't remember how I've run it in the past. Oh yeah, it was on the Windows side anyway. Do we want to work on the Windows side or on the Ubuntu side? I think I'll probably go on the Ubuntu side. So what is the version of my Python? Oh, I don't even have Python. So Python 3 version here. See, this is 3.10. Yeah, why not? Let's just create a directory here. So I don't know what we want to call this repository now. Rice trainer. There you go. Let's do git init here. Okay. Did it initialize? Yeah, he did. That's good. Yeah, first things first. Let's try and download this dataset. So it would be nice if we can download this kind of through an API, right? So we essentially download it from Kaggle all the time. But if not, we can also use something like the S3 buckets to just download the data all the time for us in our pipeline. I'm going to use my own account. I swear to God, I already had an account here on Kaggle. But yeah, how's the audio sounding, by the way? Let me know if you guys can hear me fine. The music is a little bit too loud on my ears, but yeah. So if you download this, does it download? Yeah, we've got the files being downloaded. Now let's just move them into the Ubuntu, right? So mnt c users and then my name, downloads and archive, I think it is. Sounds good. Yeah, music can be lowered a tiny bit. Thank you, Robin. Dude, I asked you yesterday, but we weren't alone, I guess. So I was also talking to other people. But when do you finish university? Because I know you're in your last year, right? At least you mentioned that. So you should be finishing soon, right, man? Hope you're excited for it. So I'm gonna unarchive this. Ooh. So 28th of May, man. That is close, dude. What are you doing here, man? Go study. Go make sure that you pass the year. I'm sure you're gonna pass, right? You sound like a really good student. So you sound much better than I was when I was your age. But yeah, man, have you decided what you're gonna do after? Are you gonna? I guess you're gonna stay in the coding industry, right? Somehow. Ah, okay, so this test is already set to it's already split, basically. So if I go into test here and arborize, still have one maths exam I need to complete. Alright. Yeah, maths exams are always the hardest for me. Oh, they used to be always the hardest for me. See, when I was at uni, well, I'm sure I've mentioned it before, but I did a kind of a dual degree where you do 50% computer science and 50% mathematics. And every time I had a maths exam, I would do reasonably worse compared to the computer science exams. It was just easier. Computer science was just easier. There's no going around it, to be honest. Like, the content that you learn is much easier in computer science than it is in mathematics. But I wish you all the best, man. I'm sure you're gonna do well. We're probably gonna start a new company soon and try to work with that after school. Nice, yeah. Yeah, you're doing the right thing, man. So if you already have experience, like coding for other people or contracting, right? That's what you really are doing at the moment, from what I can guess. Then you're gonna earn so much more money having your own company than working for a company. Don't get me wrong, working for a company sometimes is always good. Because you get experience working with like large teams and stuff, but the money is there to be made on contracting, if I'm honest. So you get more out of it. Right, so we have that. So as Manzal, and then word count. So there is 2,500 images here on the test set. That's interesting for Arborio. It's safe if you're not putting a risk when you work for another company. Yeah, that's true. So that was this test. What was the train? So last one is out. Word count. Lines. Dude, we have 10,000 here. 10,000 images. What the hell? Rice varieties fruit. 15,000 images. Jesus, that's a lot of images. But a lot of the, oh man, I'm gonna have to remove this heart because it's kind of ruining the vibe here for me. I can't read messages properly. Let me hide that shit. How do I get the heart? Like, inspect element. There you go. So it will be this, right? Yeah. Hide element. There you go. But a lot on the line when you have your own. Yeah. Yeah. I mean, I would say it's much riskier than working for a company. I mean, when you're on your own, you got to make sure that your work is always the best, right? And it works for your clients, so you can get good references for the future. And all it does is like it takes one bad client to badmouth you on the internet for you to lose future clients. So, you know, it's a lot harder to have your own company. But if you already have experience with that, man, if you already have done some projects for other people, then you sound like you're doing great, man. I've done that in the past, and right now I'm working for a company. So I've done all sorts. I've done projects for people. I've worked as a contractor. And I've you know, been in companies as well. So yeah, so we have 15,000 images, which is kind of cool. So we have 10,000 here on the train, and then we have validation. So word count ls minus a, word count minus l. Ooh. Okay, so somehow this is already split for us quite nicely, actually. So we have a test, train, and validation set, right? So what can we do here? Because my plan for today was to kind of separate images into train, test, and kind of set, right? I mean, we can still do that sort of tooling for us anyway, because not all the data sets will have this stuff. I want to find out what the difference between test and validation is, though. So machine learning, test versus validation. What is the difference between test and validation data sets? Validation data sets is a sample of data held back from training a model that is used to give an estimate of model skill while tuning models' hyperparameters. The validation dataset is different from the test dataset that is also held back from the training model, but is instead used to give an unbiased estimate of the skill of the final tuned model when comparing or selecting between final models. There is much confusion in applied machine learning about what validation dataset is exactly and how it differs from a test dataset. Yeah, I mean, I've always, when I was learning at uni, it was always called the test dataset. So I wonder why this one splits into test and validation. I still don't know the difference though. In this post, you'll discover clear definitions for train, test, and validation datasets, and how you use each in your own machine learning projects. After reading this post, you will know how experts in the field of machine learning define train, test, and validation datasets, the differences between validation and test datasets in practice, procedures that you can use to make the best use of validation and test datasets when evaluating your model, right? Okay, let's start with what is a validation dataset by the experts. I find it useful to see exactly how datasets are described by the practitioners and experts. In this section, we will take a look at how the train, test, and validation datasets are defined and how they differ according to some of the top machine learning texts and references. Generally, the term validation set is used interchangeably with the term test set and refers to the sample of data that's held back from the training model. The evaluation of the model skill on the training data set would result in a bias score. Wait, the evaluation of a model skill on the training data set would result in a bias score, yeah. Therefore, the model is evaluated on the held out sample to give an unbiased estimate of the model skill. This is typically called train test split approach to algorithm evaluation. Yeah, that's what I was talking about. But I still don't know what evaluation one. is, I'm not going to read all of that. Oh gosh, I don't want to read a massive article just to get the differences, but I guess we're going to keep reading. We're going to keep reading. Suppose that we would like to estimate the test error associated with fitting a particular statistical learning method on a set of observations. The validation set approach is a very simple strategy for this task. It involves randomly dividing the available set of observations into two parts, a training set and a validation set or holdout set. The model is fit on the training set, and the fitted model is used to predict the responses for the observations in the validation set. The resulting validation set error rate, typically assessed using the MSE, in the case of quantitative response, provides an estimate of the test error rate. So this is the mean squared error. We all know what that is, right? I guess we can see the interchangeableness directly in Kunz and Johnson's excellent text applied predictive modeling. In this example, they are clear to point out that the final model evaluation must be performed on a held out dataset that has not been used prior, either for training the model or tuning the model parameters. Ideally, the model should be evaluated on samples that were not used to build or fine-tune the model, so that they provide an unbiased sense of model effectiveness. When a large amount of data is at hand, a set of samples can be set aside to evaluate the final model. The training data set is the general term for the samples used to create the model, while the test or validation dataset is used to qualify performance. Yeah, in this test, it means the same. Still, we don't have a clue what the differences are. Perhaps traditionally the dataset used to evaluate the final model performance is called the test set. The importance of keeping the test set completely separate is reiterated by Russell and Norvig in their seminal AI textbook. They refer to using information from the test set in any way as peaking. They suggest locking the test set away completely until all model tuning is complete. Yeah, cool. Okay, definitions of train. I'm gonna skip all of this stuff. It's just like mentioning some literature and how these two terms are kind of used interchangeably, right? In other words, they mean the same up to this point. To reiterate the findings from researching the experts above, this section provides unambiguous definitions of the three terms. The training set, the sample of data used to fit the model. The validation set is the sample of data used to provide an unbiased evaluation of a model fit on the training set while tuning the model hyperparameters. So the evaluation becomes more biased as skill on the validation set is incorporated into the model configuration. Okay, so the validation set can be used to fine-tune the model if you have a fine-tuning model, I guess, right? And then the test set doesn't fine-tune it. You just use it and see what the effectiveness of the model is. Yeah, that makes sense to me now. I mean, I get it. Kind of, but I get it. So in certain models, you can kind of fine-tune the data. So you may have seen it on your phone when you have something like, well, back in the day, right, when Google used to ask you to say a word like "Okay Google" or something like that. So they have a speech model that can be fine-tuned to your own voice. So the validation set would fine-tune and then do tests based on that fine-tuning. Now the test set would just kind of run the tests without the fine-tuning. So you would not fine-tune, and then you just work out how effective the model is by just putting the data through it without any fine-tuning. Yeah, it kind of makes sense now. Right, dude, this song is good. I like it. Yeah, I mean, but let's assume that this data set wasn't already split for us, right? So what we want to do is we want to go into train, or all the images that we have, and we kind of want to split this into like 20% like train, 15% validation, and then the rest of it would be something like the train data itself, right? So yeah, let's do that. Let's see if we can quickly come up with a Python script to do that, and then we can put this on a pipeline, right? So code here. Okay. In the meantime, we're going to look for a Docker image with Python. Anaconda Docker image. Because most likely this is what we're gonna use here. In fact, can I go into the Docker hub and search for Anaconda in there? Hub the Docker, okay, Anaconda. We got Continuum IO Anaconda 3. And this will have Anaconda for us. Great. Hello, Carlos. Good evening, man. It's good to see you. We're doing some Python today, so it might not be as interesting to you guys, but, you know. I'll tell you a little secret. I love writing Python. I don't know why. I always liked writing Python. I think it's such an easy language. There's so much, like, so many resources out there. Online, you can do anything with it. Obviously, it's not great. It's kind of very slow, actually. But it's been one of my first languages, and it always stuck with me. I remember, like, when I was very young, making this bouncy ball thing with Pygame, and I was so impressed that I could do something like that in programming. But yeah, and that's the kind of shit you should start with, really. Like, just pick a simple thing like a bouncy ball or something like that, or a quick game, and then just try and make it. You learn a lot from that. I'm down for watching some Python. I know enough for me to follow. Yeah, so today we're doing some sort of code that will split the data sets when you have like a lot of images, for example, into 3 directories. So you want to have the test, train, and validation here. The dataset we downloaded, which contains images of different types of rice, it's already split for us, but not all datasets will be split for us, and we're gonna simply just kind of split it ourselves, right? That's what we want to do. So let's add a new file here and call it dataset split.py. Okay, now we obviously need to install Python in here. In fact, I'm going to install Miniconda. I'm going to install Miniconda on my Linux machine. So Windows, Linux, Miniconda 64. What is this? Shell, okay. Let's copy the link, and then let's kind of get this. Hey, hello, Sop. Good night, dudes. Guys, if you are, if you're willing to do it, please give it a like to the video. I appreciate that. So it's going through the same images, read the images, and determine the type of rice. Well, that's the idea. Eventually, we want to train the model. I'm sure we're not going to get to train the model today because that's a huge task. You need to kind of run. You need to kind of train with like something like TensorFlow or PyTorch, and then you get like a DNN out of it, right? For today's video, I just want to create some of the tools that will help us do that. In other words, I want to create the tool that kind of splits the dataset. I'm using this rice dataset, but I'm going to make it general enough so whatever dataset you put through, as long as it has a labeled data, we're going to kind of be able to split that into test, validation, and train dataset. So for example, the training dataset will have something like, 80% of the images, and the remaining 20% is going to be split into the test and validation datasets, right? That's what we're going to try and do. Yeah. For now, let me actually install this. So in order to continue the installation process, review the license, press enter. Sounds exciting enough. Maybe this gets me back into Python. Yeah. I mean, Python is just that easy glue language that everyone knows, right? It's amazing. Dude, what is this? Why do I have to review all of this? There you go. Do you accept the terms? Yes, I do. So Miniconda will now be installed in this location. Home, Miniconda, press enter to confirm. Yes, I'll confirm that. Yeah, the Miniconda installation is so much nicer on Linux than it is on Windows. Jesus, I just devoured like a whole jar of peanut butter. Dude, you know, peanut butter has a lot of calories, man. Something I learned the other day. It's basically nuts, right? Nuts are very, very high in calories. But it's the good calories, right? So you're getting that protein. Hello, Tom. How's it going, dude? Finally doing some AI live streams. So you can do this by running. Wait, what's going on? So do you wish to update your shell profile automatically? Yes, I do. Now, the thing is, this will have added shit to my bash.c, right? Pretty sure. Oh, is that shell.c? Oh no, it does. It has added stuff to my folder, right? So we can source that. We can source that shell.c, and we have conda now. Yes, we have conda. It's great. Yeah, so let's remove that Miniconda thing and let's create a new environment. So let's call this, I don't know, our ML environment, right? Our machine learning environment. Oh, let's put Python 3.12, latest and greatest Python. And I'm like, a stick, so no worries for me. Yeah. I mean, it's easy for some. Like, dude, if I eat anything that's like high calorie, I will gain weight. I've actually been on this kind of crazy diet for like maybe 3 months now. And I've literally went from 75 kilos to 67 now. And I still need to lose another 5, so yeah. But it's been difficult, man. It's been very difficult not being able to eat your favorite foods. I'll tell you that. Like whenever I see a pizza from like Papa John's and Domino's and I smell it, I really want a slice of it, but it's better if I don't, basically. What happened there? Ah, okay, so we can just conda activate ML here. That's great. And in here we should be able to Python select the interpreter, right? Okay, user bin Python. Okay, this is not selecting my Python environment, so let's try it again. I've been trying to gain weight for like 3 years. Life of a programmer, no easy. No, you're the lucky one, dude. I mean, most people are trying to lose weight, and that's really difficult. I mean, if you want to gain weight, just literally eat pizza every day for a week and see if you're not gonna gain weight. Gain weight. Select interpreter. Ah, okay. So here we've got the Python, the conda ones. No, which is good. Now the thing is, ooh, right? Why did that happen? I haven't been to the gym in maybe like 5 months. I went up at 80 and lost. I went up at least 20 kilos, Carlos. Dude, Carlos, you gotta get on it, dude. I've been going to the gym for like five times a week, I think, recently. And it's been hard work, but it's, you know, I can see some differences now. Right, so I can't see my conda. Okay, I cannot see my Miniconda environment. So VS Code, Miniconda environment, not showing. Let's see if there's anything we can do here. Control Shift P, select interpreter. Does not appear, create a Python, and try again. You can press reload icon. I mean, we have a Python, so if we just create an select interpreter, and it doesn't appear again. Yeah, it did not appear. I'm waiting for the ML stuff here. What is my... Oh yeah, this is not appearing for me. I do have Python, right? So for the Python here, yeah, 3.12, so exit. create conda environment passing the Python argument. Yeah, I've done that already. So Control Shift B. Let's try again. Let's try the Python. Select interpreter. I mean, base is there. Reactivating terminals. Yeah, it's not finding my correct one. Only base is showing. Python path is there. Can you explain that if name? I never understood that way. Ah, yeah, sure. I mean, if name is like name is a variable in Python and is the name of the current module, right? I believe it is, or something like that. So if the if name is equals, actually missed that, main, that means that this module was called as the primary Python file, right? So if you called it with Python run or whatever, you know, Python, and then the dataset split.py, this will be main. If you call it as a module, this will be the name of the module, I believe, right? So basically, this only runs when you call this Python as the main file. That's all it is. Nothing too difficult. Yeah, dude, I did that. So conda activate ML. Let's code again. Yeah, so that's basically main for Python. Yeah, that's basically the a way you can hack that. Yeah. Oh, finally, he finally found it. Here, there you go. We have the right stuff now. Yeah, so we have that, and now we're gonna need a few functions, right? So let's see. First function we need is something like let's model the folder. Do we even need to model a folder? Probably not, right? So what we want to do is essentially like have a function that we can say split dataset, and then we're going to pass in the test ratio, or in fact the train ratio, the test ratio, and we don't really need to pass in the validation ratio, but that can be something as well in here, right? Yeah, we can create a class for that. So a splitter, dataset, dataset splitter. So def init as usual, self. We're going to pass in those values, so the train ratio, test ratio, validation ratio. And in here we can do something like self dot train ratio, self dot test ratio equals test ratio, self dot validation. Okay, yeah, we got all those functions, and I guess what we can do is something like this, right? Like that's how you think it. That's how you say to Python it's a class variable, I believe. I finally managed to create and upload a new YouTube video today. Been on my to-do list for a while now. Drop us the link, man. I'll react to it if you want. But anyway, drop us the link, and I'm sure everyone here is gonna like it, dude. I'll like it right now for you, and I'll keep it playing on the background so you get that watch time, and therefore YouTube recommends it to more people. So yeah, you can drop it on the Discord, by the way. I'm not sure if you'll be able to post the link right here, but as I said, Discord might be your choice there. So we have is it property or something? So train ratio. I'm gonna do this over and over again, right? So yeah, actually, to a property def Okay, we did it twice. So validation ratio, and we're forgetting the self, of course, in all of these. I think it's property, right? That's how we do it. It's radio related, so may not be the most interesting. Dude, I find that interesting anyway, so please send it over, and then we'll like it, man. Don't worry about it. As long as we get you the views, man, that's what matters. Okay, so yeah. Python property decorator, yeah. Is it property? I believe it is, right? Yeah, it's a decorator that basically lets you call it like it's a property one. It's a built-in decorator for the property function. It is used in a special function. Okay, yeah, cool. In what channel should I send the link? Dude, just send it in general. Just be like, hello, this is, I created a video. I'm happy to let you advertise that, dude. You've been part of the channel for quite a while, and yeah. Make sure you say what it is, so if people are interested, they can go and take a look at it. One thing we gotta see here is like make sure that if the train ratio or the sum of train ratio and we have test ratio and validation ratio isn't 1. Oh, this is not Python. This is not Rust. Then we're gonna throw an error, right? So we're gonna raise. Okay, how to do errors in Python? So Python exceptions, right? We just got it inherited from the exception, I believe it is. Hello, Antonio. Boa noite, bem-vindo. So we're gonna. Yeah, there you go. Except runtime exception. That's the one. That's what we gotta. So data splitter error, and then we pass in an exception here. And we can have an init, right? On this. So error message, which is a string. I guess this should be a float, and that should be a float as well, and that should be a float. And then we can do dataset splitter error. Ratios must add up to 1. I'm going to create another one just for the sake. Oh, no, I can't. Wait, how do I override the exception error? Python override exception string. So we have, okay, lambda exception in it and a string. Okay, this string is just what we need, I guess, right? So self doc and string. What you want to achieve is this. So dunder methods lookup is different in Python for custom classes. Implicit invocation of special methods are only guaranteed to work correctly if defined in an object's type, not in the object's instance dictionary. So what do we need? We need string, output ABC. Okay, I see. So yeah, I guess we can do self.error msg equals error msg, and then we can put that, slap that in here, and then just do something like we return the self.error msg here, and we don't have self. Forgot about that, and we're good to go, right? Right, and obviously we want to have a method called split, right? So where we're going to actually split the directories, right? So we have a method called split here. And what does that return? I guess it returns I guess it would be nice to return a dictionary saying. I don't know actually. I don't know what should this return. I definitely want to kind of return a list. Of like test, train, and validation, and say here are the images or whatever in each test set, in each split set. Split the given data set. Splits the given data set by train, test, and validation directories. Yeah, I don't know what the return should be, to be honest. And then we can say where the destination is, right? So destination can be a string here. Puts the train, test, and validation directories inside the given destination, creates it if it doesn't exist. Okay, yeah, we can do that. We can call something like os.path. I think we're gonna need path, right? Yeah. Because here we can do all sorts of things to the OS. So we can join, os.path join. We can create, no, we can't create things. Maybe a split object with 3 attributes being train, test, and set validation, each being a list. Yeah, I like that. So one good thing we can do is, there's this nice thing in Python called a named tuple, I believe it is. So we can use a named tuple for that, instead of creating another class for it. And yeah, we can do it like here. So split result, right, or something like that. That is literally going to be a named tuple. Now this is interesting. So what should it be? This is the name of the thing. So split result and an iterable of string. And these are okay. Yeah, I mean I like this one, but I think there's another one that actually is kind of type safe. So typing. It's a name tuple, there you go. So this one is a little bit better, I think. So name tuple, this is equivalent to employee. Okay, yeah, this one takes a type, you see. That's why I like this one. So we can split result. Oh, I didn't know about that one. I love it. Oh yeah. It's a good one. So we can have, you know, the test, which is going to be a string. Oh no, it's going to be a list. Wait, can we have a list? A list of... How does this work? Alright, let's try this. So list. Does that work like this? I don't know now, you know. Is this what it is? Alias of list instance one. Okay, yeah. So it's just a list of strings. That sounds good. And then we have the validation, which is again. Oh no, this is a different one. So we have the validation set, which is a list of string as well. And those would be the paths, right? And then the train, right? The train set. List of strings here. Beautiful. And we can kind of just put this in here, right? I guess. I don't know how the Python linter is gonna like, if the Python linter is gonna like this or not, but this is what we have here. And there you go. In fact, can we just remove it by 2? There you go. Right, let's hope this works. So, right. Yeah, so now we can come down here and say that we're going to return that value, right? So split. By the way, Antonio, I know you do Python, so let me know if there's any cool tricks that you know, dude. I also like Python, but there may be things you know. So split result, right? We're going to return a split result. That's all we're going to do. Now, what's the plan here? The plan is to read the input directory kind of randomly. Split the files inside the directory into 3 sets, right? Based on the ratio that we got given. That'd be quite cool. And then at the end of it, we simply create each directory and put the ratioed images into each. Now, one thing that we have to notice is that like some of these directories are quite big, right? They are quite big. So if you go into train here, and if you go into the arborize, because that's the dataset we're using. Out of interest, if we do xdg open 654, what does it look like? This is the picture that we can get from it. It's a picture of a rice grain, right? But anyway, so if we do an ns-l wc-l, we have 10,000 images here. What we don't want to do is the naive approach where you just load all the images here and then split those images into individual arrays, because some of these names can get quite large, right? It can get quite large. So we don't want to kind of load 20,000 of them into memory. That's what we don't want to do. So what is a better way of doing it? So obviously we gotta kind of find a way to page these things, I guess. Right? So let's see what we actually get out of the OS. So OS, or maybe even we can take a look at online and do file utils Python or something like that. Okay, so this is not what I wanted. I kind of want a way to open a directory in Python but not load all of the children into memory, like as a path, basically. What is the header to do that? File utils. Okay, sheetil sounds good. What is that one? The shell util module offers a number of high-level operations on files, collections. Okay, warning, even the higher-level file copying functions cannot copy all file metadata. On POSIX platforms, this means that the file owner and group are lost as well as ACL. Okay. os.listdirs, I believe. Okay, let's try that one. For both files and directories inside. Okay, but that will load all of them into memory, right? I mean, it's probably not a problem straight away. So os.listdir, you said? Let's just import os. What does that do? Okay, there's no... I want to look into the documentation. List here. It returns a list of the names. I may have misunderstood them. No, that's good. That's what we want to do, Antonio. But what I also don't want to do is load all of them into memory at once, right? It would be nice if there was a way to kind of load 10 at a time, but I don't know. This is perhaps asking too much of the Python standard library, isn't it? So returns a list containing the names of the entries in the directory given path. This is the list. This list is in arbitrary order and does not include the special entries that even if they are present in the directory. If a file is removed from or added to the list during the calls to this function, whether a name for the file can be included is unspecified. Path may be path-like object if a path is of type bytes. Okay, this function can also support. Okay, so there is no way to just say, you know, take me the first 10 out of these, right? Which I guess, you know, not that bad, I guess. Hello Slim, how's it going, dude? I burned my dinner. Oh man, what are you making? Like oven pizza or some shit? Dude, you gotta be on it. Python list dir stream. That's kind of what I want to do. Yeah, alright, lol. Maybe the IO library can help with opening them one per one. It has some buffer likes byte IO. Cool, yeah, I'll take a look at that one. I mean, what does an average kind of path looks like, right? So this is an average kind of path. So if we double this, let's do some kind of quick maths here. So we have calculator up there, and we have the character count. If we double that twice, we have 104 characters, right? So that's 104 bytes-ish. So 104 bytes, and if we times it by, you know, in this particular case we have 10,000 images, but say we had a lot more than that. Say we had 100,000 bytes, right? So that's what we're gonna have in memory at one given time if we load all the paths in kind of absolute paths, right? If we want to divide it by A to get the number of bytes in it, so we have this, and how many megabytes do we get? So byte to megabyte. So we have 1.3 megabytes. Now, is that a problem if we have that many files? I would probably say that no, it's not, is it? 1.3 megabytes in RAM is nothing, guys. Absolutely nothing. So let's just do the simplest way here. It goes back to my short that I made the other day. Just keep it simple. We don't have to open every file, you know, all at once, but we can hold all the paths all at once. I don't think that's an issue. Because even if we have like 200,000 images, then, you know, it's 1.3 megabyte per 100,000 images that we have, 100,000 paths. So this becomes a problem when it's something like 100 megabytes in memory, right? So basically we can have, yeah, I don't know, like a lot of images, basically like millions of images, and we still won't have a lot of memory being used up, which is good in terms of bytes. So yeah, let's do that. So OS list here, and we have something that actually does something, I guess. So the paths here, or paths. Now we kind of want to randomly pick these images, right? So we Python remove from list. I want to remove an index from a list because now we can kind of do the splitting where we remove one image at a time and copy that one image at a time, right? How about walking through the directory and getting a range of files? Yeah, so that's what list does, Carlos, I believe, right? So if we do, oh, there's no optimizer here, so we can just put a breakpoint there and kind of debug this, right? Let's try that. Python debugger, and let's call that. First of all, what do we have here? So dataset splitter. Dataset splitter. And we need to have 0.3 and then 0.8, 0.1 and 0.1 here. Right, so we've got that. Let's run and debug the Python file. Okay, so what is this doing? Test ratio. Wait, what the hell? Maximum recursion depth. What the hell? I don't understand what just happened there. Why is it giving me the maximum recursion thing? It says split to error. Right, I don't understand what just happened, but let's see. Because that was quite interesting, wasn't it? So if you look at the splitter, why are my test ratios and everything like that? Ah, yes. Never mind. That's why. It's because it's a recursive function. If I don't put these here. So test ratio, string ratio, test ratio, and validation ratio. Come on, guys. I thought you're spotting all of my handwritten mistakes here. Okay. Now this should kind of work fine, right? Oh, no it doesn't. Okay, but it goes into splitter now, which is good. Takes one positional argument, but two are given. Oh yeah. Let's try and do that again. We just forgot about the self. Okay, and that kind of works now. That's beautiful. Yeah, I do want to put like a little print here, just so we get the value that's coming in, and I can see what the paths are. Yeah, okay, so this just lists the directory to the current one. We have validation. Okay, cool. It would be nice if we can also put the path here, the path that we want to split. Or in fact, the source and the destination, right? That's the best thing we can do. All files within this directory will be copied to the split directories. And now we have destination here, which is I guess the path where all the split images will be put into. Right, that's it. Antonio, about the removing items from the list, you could make a loop and keep popping. Yeah, popping from the list. Yeah, that's good. That's good. That's what we want to do. Yeah, so we can list a div, and does it take something? Yeah, it takes something. And we can have the source here. And yeah, let's loop through all these things now. So for each path in all paths now. And this will kind of define, like, how do we define which directory it's going into, because we have a range, right? And we kind of want to make sure that the ranges are correct, I guess. But I would also like to randomize this. So can I randomize the paths here? Yeah, randomize list Python. random shuffle. Yeah, we can do that. So random shuffle, let's do that. Import random. Also from random, import shuffle. Oh, do you use a random shuffle? Yeah, cool. I got that. Thank you. Thank you, dude. Yeah, so it's randomized now. Now all we gotta do is like pick an image for the training, and then pick an image for the test, and then pick an image for the validation. Right. So what is an easy way to kind of decide here, right? Because we want to do something like, if the range, or if some value is within the range or something like that, then we pick it for the train. And before we do that, we can also probably start recording that information on the return value, right? So the split result is a split result here, and then we can have lists. Okay, yeah, we've got that. So basically we want to say, result.test dot append this particular image, so the path somewhere. As well as kind of copying, so where's the copy? Is that right? Copy file range. I'll do copy files in Python. File Python. There you go. Util. Yeah, we can do that. Why not? Oh, what is copy to? Copy and data and metadata retain the file destination. Metadata is copied with copy stat. Okay, yeah. Copy to seems to be the one for us. Copy to, and then we have the source and the destination, right? So we have the source, which would be the original path, and the destination is going to be os.path.join, and we have the destination here, and os.path.base name, I believe it is, right? The final component of a path, and that includes the extension. Hopefully, returns the tail. Yeah. Okay. Cool. Okay, that should do for us. I mean, this is kind of what we want to do. And yeah, now, as I said, we want to basically just pick things based on the ranges, right? Yeah, it would be nice if we had like a take kind of thing here in Python. Yeah. I mean, as long as the number, I guess the... Okay, let me see this. Let me think about this now. Because what kind of maps can we use here? So we can do something like if the result dot test, I guess, dot size, right, or the length of it. So the length of that is more than, or is still less than, I guess, the self dot ratio, test ratio, times the length of all paths. I mean, I don't like the length of all paths, right? So we can do number of files here. Reason is we just cache that in there, length of paths. Given already consuming, take the first 10% slice and test. Yes, that's what I'm trying to do, Antonio. So like basically do it up on the ratio itself. And yeah. So end files. Yeah, so this kind of goes like this, right? So if the number of images that we have copied over is still less than the number of images we should copy over, then we're gonna still copy it to the test set here, right? That's what we're gonna do. And obviously we're gonna join destination and path name. Wait, does join only take 2 of them? Oh no, yeah, it takes 3, so we can do something like that. So let me just see if this will do what we join 2 or more component path names together, inserting this as needed. Insert analyze the first part. Okay, yeah. Cool. And then we can do the same thing for the other ones, right? So same thing for the other branches as well. So something like train is going to be test ratio, so train ratio. We got to make sure that we copy all of these, so we change all of them. We don't have any tests remaining on that. And then here we have validation, test ratio, train ratio, validation ratio. Ooh. Yeah, I think this is it really. This is our function. It does what it does what it does. So we have result, validation, and then of course at the end of it we're going to return the result, right? That's what we're going to do. So let's try and test this out. Now, one thing I kind of want to add here is the doc opt, right? So we can do a quick doc opt in Python here. So let me use the GPT just to get us a thing here. I think it can put doc opt Python install. Hello Robin, you're back. Did you post your video, dude? I'm still looking for. Oh, trying the wrong thing. I'm still kind of waiting to see this video. This high production radio video. So pip install doc opt. Okay, yeah, let's do that. Okay, and we have doc opt there. We don't need that one. We have so we're going to import doc opt, and then we can see how it's kind of used in here. Let me get that GPT output, because we're going to just, as a good programmer, copy and paste this right into our program up here. So this is a Python 2 that splits chain. Ooh, test and validation. Images for a machine learning training algorithm. Okay, so we have source and destination. It would be nice if we could pass in the arguments like as a flag, I guess, right? Kind of like that. So yeah, let's do this. And here we're gonna pass in the source and the source src. Shit, right, we'll post it now. No worries, dude. I mean, marketing, you know, making the videos is part of it. I would say the marketing is the most important thing when you're starting out with YouTube, man. In fact, that's something I still struggle with. Like, I struggle to get people watching my videos. In fact, if you guys haven't yet seen, please watch the latest video. I basically just like summarize what I'm doing for Urchin in Golang, and I'm just mentioning to people how they can make an application with the same stack. So yeah, I mean, you guys are probably already aware of what that work is, but you know, it's a shorter video to just get people kind of wondering like how they can make really good apps very, very easily with Golang. So yeah, please watch and like that. I'd appreciate it. Like, share, and subscribe indeed, yeah. DST. And then we have the destination. Okay, I think we kind of have it, right? Options. And we have to parse it like this. Doc.opt. Okay. This is like a quick alternative to the Python argparse, right? So we have arguments, and then we can print the arguments. Yeah, I guess we can do it from doc.opt import. I feel like completely focusing on the hate stack. What is the hate stack? I don't. Is that an actual stack or just a joke that you made now? It's a HTMX. I don't know what the A stands for. AngularJS. Fuck knows. Oh shit, swearing. Ah. I need to stop swearing, man. I need to stop swearing in my videos. Yeah, so where are we on now? Yeah, let's see if we can. HTMX, Alpine, Tailwind, Echo. Nice. So what's the actual backend? Echo, I guess? Echo. Oh yeah, Echo is the Golang framework. Never mind. So Golang is the backend. Cool. And Alpine should make it fairly lightweight, isn't it? Function object has no attribute doc.opt. Okay, yeah, that's correct. That's because I imported it before. Let's try it again. And also, this should have not been here. What the hell? This should have been down here. What am I thinking? So expected a string type and it got none. Why is my doc string not working? Is it because I have to put it right at the top, I guess? Oh yeah, I have to put it right at the top. Otherwise it's not a Python doc string, is it? There you go. Let's try again. So what is going on here? So usage. Okay, yeah, we just haven't passed in the right thing and it gives an error. That's fine, that's what we expect. Doc.opt exit, yeah. So we have to create a launcher file, right? I guess. Okay, so we create a Python debugger here. File splitter. We're going to do debug py, and then we do our workspace folder, and then we do dataset splitter.py here. And for the args though, this is where we got to set in the other stuff. So src workspace folder. I don't know, let's put a train in here, right? I guess. Obviously this is not going to work because it expects one single string in each thing. And then we have dst, and then we can have the workspace folder here, and then I guess test split, something like that. Let's put that in there. Now, are we going to get an error? Are we going to get an error? Why are we getting an error? What is the issue? What is the issue? No such file directory. Rice trainer dataset split. Oh yeah, dataset split. That is why. That made complete sense. And of course it works now. So the arguments, we still don't have that. Let's just change some of the stuff here though. So what do we have here? The version's not quite right. I'm actually enjoying the Python content right now. Thank you, Carlos. I'm glad you're enjoying. I mean, as I said, I absolutely love writing Python. It's just so easy. Like, we get so much done very quickly in Python. It's unbelievable. I mean, I feel that with Go as well. Like, I feel like with Go, whenever I sit down on a stream for 2 hours and I plan to do something, we manage to finish this stuff most of the time, right? I think there's been quite a few, well, not quite a few, but very few streams where we actually do a Golang stream and we don't finish what we want to do by the end of it. Whereas if you look at all my C++ videos, or my C++ streams in fact, you know, it happens quite a lot where I start something and I'm not able to finish it on the stream because, you know, it's been like 3 hours, 2 hours, and I'm stuck on something. So it's, you know, it's always better to stop and then come back at it later. But yeah, I like Python anyway. So what is the issue? So usage, inline, arguments.copt. Yeah, so most likely it's this thing here that's wrong. So dst equals that. Okay. So this is one of what we see. If I had one of them, so set remove. Yeah, okay. So basically, this is what I want here. And then we can have the options there. This is what happens when you don't write proper man pages, I guess, right? So this is dst. And I'm pretty sure we can also do something like this. Dst equals dst. Okay. Let's see if that's better. Always compiler's errors. No, this is not quite the compiler one, this is the interpreter error, which I much prefer actually to compiler errors. So, I mean, the thing is, why isn't this working? It should be working. So either that or that. Maybe, if we do it with one of them, does it work? So if I just do this. No, it still doesn't work. The usage is that or that equals DST. I mean, I guess I could kind of do that. If I don't put the equals there, is that the problem? No, it's still... What the hell? What the hell? What am I misdoing here? What am I not doing right? Because in this case, they've got like a positional argument here, and a command, and then X and Y, which are other positional arguments. And then they've got like an optional flag here, which is what I wanted. And then it puts it into a map like this. Yeah, we know that. But .copt parse flags with values. Python. I mean, this is the same example we saw earlier. U model v s destination and plot name. If I just put, you know, just for the sake of getting this done, if I kind of just put a short thing here, does it work? Oh, we've got some nice Mexican music now, I guess. No, it still doesn't work. Come on, dude. Come on, come on. I was talking good things about Python. I was saying good things about Python. Now it's giving me random stuff. There you go. So operation. Options, operation, square option. I understand, take me to the website, please. Oh no. Never mind. Do not take me to the website. Oh, it's .copt.org. Why can't I? Required elements or another. Mutually exclusive elements can be separated. Okay, so we don't want that. We don't want mutually exclusive. We want one or the other. Required elements, either this and that, or this. And we can have multiple files, that's fine. Oh. Options is a shortcut that allows you to avoid listing all the options from a list option. Okay, so can I have options and the files here though? So if I do something like, just for the sake of it, is that how it works? The shorthand and the long form. There you go. Okay, is this a little bit better? I don't know now. No, it's not. I am getting sick of this now. Why is doc opt not working? I'm just gonna switch to argpars, I think. I thought this would be a nice addition, but clearly not. That is copyright strike. I got a copyright strike with that song the other day, so I'm gonna skip it. It's just in a different playlist. Doc opt for dummies. I'm a dummy. Can we do a doc opt tutorial? And reminders. So what do we have here? Usage remind. Oh, it's 5. Either return or end reminders. Yeah. What if I do SRC now? But I also say this. And if I do DST, but I also put equals to that. Does this work? No, it doesn't. Yeah, guys, we're switching to to argpars now. I can't be asked anymore. It was nice, but it didn't work. Doc opt doesn't, you know, it's kind of hard to figure out which particular format you should put things in. So argpars is the one. Right. So let's see how we can do this here. So argpars, argument parser. Program name description, and then we can add the, okay, yeah, this is easy enough. I can understand this easy enough. Let's remove the doc opt stuff, and we don't care about that anymore. So we need argpars. So import OS, import argpars, program name. This is the dataset splitter. We don't need this. Parser.add argument. Now, there's a bunch of things we can add here. So we want to add, I guess, is it the short? What is it? So we want args. Okay, args doesn't really mean much here. Add argument. So we want to pass in the dash s or src. Now there are types here, right? What can we have? I guess type is going to be a string. Default, yeah, default is going to be, but there is no default, right? Required equals true, yeah. The other required is going to be equals true as well. This is the destination, DST. Okay. Okay, so how do we parse args now? Parse args, okay, just that. And how do we get the arguments now? Parse args, args.accumulate, integers, metavar, type. Add argument integers, metavar, n. N args, one or more. Help an integer that accumulates things. So args.accumulate, args.integers, okay. So how do we get the name of it? How do we get the name of the argument? Maybe we just pass it here, so destination. Let's see what happens when we actually run this. So option string source must start with a character dash. Okay, is there a name or something on this? Name? No. ID? Yeah, like how do we get the sum? Like arguments, destination, accumulate. Okay, so DST is the one. What is DST? Okay, so source. Okay, maybe that works now. Let's see. Are you guys still following? How are you guys doing? Sorry, I got bored for a bit, but we are doing better now, right? So we have class variables. Now I wonder what special variables are. No, it's not. Function variables. Destination. Why is destination anywhere? Where is my destination still? Surely it will be in the dictionary somewhere, right? So default, get args, arguments anywhere. Action groups, get values. There you go, so we do have some stuff here. But where are the actual values though? So get values, get value, special variable. Yeah, I mean, I guess it should just work, right? So if we do something like, you gotta make sure that the parser.source isn't empty. But if it is empty, I guess we're gonna return. Print help. That's what we're gonna do. os.exit. Is exit a thing in OS? No, but sys.exit is. And if the length of parser.destination is 0, then we do the same thing. Okay. Now we actually test the thing after a few minutes. Sorry about that. We have parser dot source and then parser dot destination. Right, I think that should work now. Let's see. Let's take a look. Oh, okay, so there is no attribute called source, no attribute called destination, right? I'm still confused. How do we get the attribute from the argument parser? Yeah, I'm just confused still. We do have parse_args there, right? We've got parse_args. Ah, okay, yeah. We do need to actually put it into the arguments. There you go. It's not the parser, it's in the args. That makes more sense now. That makes more sense as to why we couldn't find these values before. There you go, destination and the source. It's amazing. So this should work now. Oh, what is args.description? Yeah, that's correct. That's destination. Okay, and now we can do. What is the issue? Source. Okay, yeah. Again, we want args here. Just a typo. Okay, so we have all the paths somewhere, right? No, yeah, this is not quite right because we don't have any images there. Let's change it to train. Wait, what? It should have been right though. It should have been right into. Okay, yeah. So I see what's going on here. Let's put another one, Arboreal. Now that should have a lot of images. By a lot I mean 10,000 of them. So okay. We got all the paths. And these are all the paths. There's way more, as you can see. And then we shuffle it. Shuffle is actually quite quick as well. Very quick indeed. And then we go for each path. And this is where we copy things to. Now we're going to have an issue here because the directory destination doesn't actually exist. So I want to see what happens there. In fact, there's a typo here anyway. Where's the destination giving us now? Okay, so we got into split. This is where it fails. There you go. So in essence, what we have to do is create that directory, right? So create recursive. Is there an OS way to do this? So OS dot create there. Make there or something. Make this. There you go. So make this create a leaf directory and all intermediate ones. Works like make dir except that all intermediate path segments, not just the rightmost, will be created if it doesn't exist. Okay, great. This is what we want. Destination. I can see that Robin posted the video on the Discord. Just got a message for some reason. So if you're not doing now, if you haven't already done, please go and check it out, guys. Go on the Discord channel and then make sure you drop a like on Robin's video. Show the support. And what really helps as well is if you watch the entire video. Even if you don't understand it, just watch the entire video and then drop a comment at the end of it, because that kind of triggers the YouTube algorithm to show people. No worries, Robin. So yeah, I mean, Carlos, if you're still there, dude, Antonio, if you're still there, check out Robin's video on Discord. I think I know it's gonna be good because I've already watched some of his videos. But yeah, drop that support in there, guys. That's what I'm saying. So make this. We want destination. We want os.path.join, and then destination here. We want test, and we kind of want to do this 3 times. So test, train, and validation. Okay, now this should be better. No worries, man. We're here for that. I'm here playing with the dogs. Yeah, Carlos, if you're playing with the dogs now and you can't watch it right now, make sure you check out later, dude. I think it's, you know, it's good to show the support. Okay, so now we should be able to copy it, except we can't. Why? File, dataset split pi. So it's gonna copy the source. Ah, okay, yeah, this file doesn't exist. That's fine. Source path. Where's the path.join? And then we have the SRC here, and then the path itself. Ooh. Right, that should be better now. What the hell? Okay, create if doesn't exist, I guess, right? That's what we need to do here. So you want to create these if it doesn't exist. So create paths if they don't already exist. I got plain right now. Nice, dude. Thank you for the support. So the def. I want to check if it's a directory. Is there? I'll say, so if the path doesn't exist, and it's, well, if the path exists already, then we don't create it, right? That's what we gotta do. We gotta raise a dataset split error, say yeah, so I'm just making the function to create the paths if they don't already exist, basically. It's nothing too difficult here, to be honest. So that should have been a string. So destination, and then we also have test. If it exists and it's not. Okay, so we can do something interesting here. So paths to create. Gotta go, guys. Keeping up the stream in the background. Have fun. Thank you, Carlos. Thank you for joining today, dude. And I hope to see you next time, man. Have a good evening. So we gotta... Don't forget to like the video, though. That might be it too. So yeah, now for each I guess path, and so we got path and their name in paths to create. We can do this if the path exists and os dot make this, yeah, there you go. Now we can do an f string here. We can just put whatever their name here, and then this whole thing would simply be the path itself. Great, and then we create it if it doesn't already exist. I guess this is really another if, right? So if, not os path, dot is dir, if it's not a directory, if the path is not a directory, then nah. Otherwise we're going to continue. Okay, yeah, that makes more sense. And then whenever I had them being created here, we can self dot create paths and the destination. And we can put it all in here. Good, yeah, let's try it out now. So hopefully, a little bit of luck, we can actually make the paths. So create paths doesn't have the colon in a Python function, that's fine. Create paths that don't already exist. Now testing, does it actually create them? Yeah, we can see here, we can see split, and we can see all the paths in there. That's good. Now, can we copy one image? That's the source path, arboreal. We copied over, and this went to test, right? CD test. Oh, so CD split test. Yeah, we seem to be able to copy all of them. Now, how long does it take for this to finish, though? That was very quick. That was very, very quick to copy all of the images. And okay, good. Now the thing is, I set the ratios to something like 0.8 for the train, right? I believe it is. Is that correct? So 0.8 times, I think it's 10,000 or something. So 0.8 times 10,000. That's 800. So 8,000 images that I can expect to be on my my train directory, right? So let's see if that's correct. If we do ls minus a, w count minus o. Yeah, I mean 8,001 actually, which is, you know, within the margin of error, I would say. I'm not too fussed if it goes over by 1 or whatnot. And likewise, I have kind of 10% on my test, I believe, right? Yeah, there is something I can improve here though already. I can already tell. We can firstly nuke. We can nuke this less than here and put less than or equals to, because that's what it should be, right? It should be less than or equals to, not less than. Yeah. And let's also nuke the split directory. Let's try it again and see how fast it runs. I'm actually going to time it, sleep. Okay, yeah. Okay, CPU 2.202. Okay, so if we time the Python is a dataset split, and then we do SOC equals whatever it is now. So we have the current working directory, and we have what else? Train arboreal, and we have the destination here. As the again the current working directory, and then we have I think split, right? That's all we're gonna do. It was very quick to copy over that many images. Yeah, very quick. Obviously, you know, copy 2 seems to be a, you know, it goes down to the OS syscall, so it's as fast as that is, really, isn't it? But anyway, so if I go into train now, and I do an ls -l word count -l for the lines, we have even more images. We should have had, I guess, only 8,000 images, right? Oh no, yeah, we have 10,001 here. I mean, I'm not entirely sure why we're copying one image more than usual. But, you know, it is what it is. Let's take a look at what we have. On the other images. Oh. Because I expect 1,000 in each one of the other ones, right? So if I look into train, for example, or test, and I do that word count -l. So you have 1,002. Yeah, somehow it's copying 2 images over every time, right? So for the validation here, it's 999. So validation has 999. Now the thing is 999 plus 1,002 plus, I think it was 8,002. That adds up to 10,003 images, which, you know, means that we're leaking some of them somewhere that we shouldn't be. Yeah, interesting. So which one are we doing first, out of interest? We're doing test first, so test always gets potentially the most of them, right? And then we can pop it from the list as well. Yeah, the path should never be the same though. I don't understand where the 2 extra images are coming from, to be honest. That's very interesting. Because we do all paths, we cycle through all the paths here, and we copy 1 image at a time from the source destination to the... Yeah, like, where the hell are the 2 extra images coming from? This is so confusing right now. So if I do train arboreal, oh no, that's right. There are, yeah. What did I get here? Okay, great. Yeah, no, it's correct, guys. I was just, for some reason, I just miscounted the number of images. There are 10,003 images, which is what we end up with anyway. You know, that means that this stream is gone. We didn't manage to actually do one of the important things, which was actually to put this on a pipeline so you can just download images from an S3 bucket or something and then split them into the set. But we can do that next stream. It seems like you guys are enjoying the Python content, right? So I'm gonna do that again at some point, maybe in 2 days' time. And I probably will be very absent tomorrow because I have I've got a production event, so things are going live basically, and yeah, I'm gonna be working until 5 AM basically. That's the problem. I'm going to be working from all day and also all night. Python is easy to watch as well. Yeah, thank you, Robin. Thank you, Antonio, for joining. But guys, next time let's do some actual Python on the pipeline. Let's put this up on the GitHub Actions, and let's try and set up something that we'll download from like an S3 bucket, and then we can test all that stuff. So essentially, anyone's going to be able to put their data on an S3 bucket and then download it on the pipeline. And then the stream after that, we can do something with the training, right? So we can actually train a neural net using PyTorch or TensorFlow, and I need to research some of that because I've not done that in years, so that's going to be interesting. But yeah, thank you all for joining, and I guess I'll see you guys next time, right? So have a good evening, and bye bye as always.